On this extension sheet, we have a series of 6 questions which are aimed at students between the ages of 13 and 16, depending on ability. So all you need is GCSE knowledge to do these questions. So let's get on into how to do these questions. So first question, we have a function machine. So we've got an input A and we're told we're going to square it, we're going to add 3 and we're going to multiply by k and we're going to get an output of b. And then also we've got an input A, we're going to multiply by k, square and add, and we get the output of b. So we want to work out an expression for A in terms of k. So if we do this expression, what we realise is that b is going to equal a squared plus 3. So a squared plus 3, and then we're going to times by k. And if we do this expression, we're going to get b is going to equal to a times k squared plus 3. And if we want to get an expression in a in terms of k, then what we need to do is eliminate the b's. So when the b's must be equal. So therefore this must equal this. So we've got k a squared plus 3 will equal k a squared plus 3. And multiply out these brackets, we get ka squared plus 3k will equal k squared a squared plus 3. We want to get all the a's onto the same side because we want to get a in terms of k. So if we take the 3 to this side and the ka squared to this side, we get 3k minus 3 equals k squared a squared minus k a squared. And then what we can do is we can factorize out the a squared. So we get 3k minus 3 equals a squared brackets k squared minus k. And dividing throughout by k squared minus k, let's just take out a factor of 3 here while we're at it, because it's always good to factorize things. And we realize we can factorize this while we're dividing by it. So we get k times k minus 1 equals a squared. And we can see that the k minus 1s will cancel. We're told that k is not equal to 1. That is important because if k was equal to 1, we'll get 0 over 0 as undefined. So therefore k cannot be equal to 1. And therefore we get that a squared will equal 3 over k. And we're told that a is greater than 0. And that is important because when we square root this, then we realise we get the positive square root of 3 over k and not the negative square root of 3 over k. Right, looking at this question, for any fixed value of x, which of the following expressions has the largest value? Now the trick to this is to multiply each one out and to spot that all of them have the difference of 2 squares. In case you're not familiar with the difference of 2 squares, I'm going to write it in the same way they write it. If you multiply out an expression like this, when you multiply it out, you'll get k squared minus a squared. And all of these are of that type. So you get 2 squared numbers, which means you know they're positive. So you know this is positive and you know this is positive. So if we multiply this out, we get k squared minus 1. We multiply this one out, we get k squared minus a quarter. Multiply this one, we get x squared minus a ninth. And multiply this one, we get x squared minus a 16th. So we know that x is positive and we know x squared is positive. So the largest value is going to be the one where we take away the least amount. So this one here is our largest value. Right, a straight line has an equation ax plus by equals k with a, b, k all greater than 0. So find an expression for the area bound by the line, the x-axis and the y-axis. So let's just grab some axes while we're here. And because they're all 0, we only need the positive axes. We don't need any others. And I'm just going to get myself a line as well. Here we have our line. Now if a and b are positive, the reason I know my line must go like this, if we were to rearrange this, then what we get by minus equals minus ax plus k, and therefore y equals minus a over bx plus k over b. And we can see if a and b are positive, then the gradient must be negative. Okay, now if we have y equal to 0 in this expression, then ax must equal k, because the y equals 0. So x must equal k over a. Now k and a are positive, so that must be where we cross the x-axis, because y equals 0 all the way along the x-axis. Looking at where x equals 0, we get by will equal k, because the x equals 0. So y equals k over b, and we get that value there. So we can find the shaded area between the line, the x-axis and the y-axis by doing a half times k over b times k over a. And that just equals k squared over 2ab. Okay, on this question, now this one is really quite a nasty question, this one. You do very well to get this one right if you're a GCSE student. So, going through this question, what we need to do, let's just draw some axes. And let's just draw a line. Okay, so I've got a line where the equation is y equals mx, and I want to reflect the point 1, 0 in this line. So effectively, if I reflect this point in this line, what I know is I'm going to have a right angle here, and I know that the distance here and here are going to be equal. So the easiest thing to do is to work out the equation of this line, find that intersection there, which will then give me my x distance here and my y distance, and then I've got my same x distance and y distance there to find that point. So that's the process I'm going to do. So I know that if this gradient is m, then the gradient of this, because it's perpendicular for a reflection, is going to have a gradient of minus 1 over m. So my new line is going to be y equals minus 1 over m x plus something. Yep, I don't know my intercept, but I do know it goes through 1, 0. So at 1, 0, put 0 in for y, put 1 in for x, and I get my c value is equal to 1 over m when I take that to the other side. So I know the equation of this line is y equals minus 1 over mx plus 1 over m. And I know it's going to intersect this line where the y values are equal. So I want to solve these simultaneous equations to find the x value where this crosses, and then I can find out where the y value is. So if the y values are the same, then this must equal this. So we must have mx must equal minus 1 over mx plus 1 over m. And times throughout by m, squared x equals minus x plus 1, because that makes my life a lot easier. Get the x's onto the same side, so I get mx plus x equals 1. Factorize, so I get x is m squared plus 1 equals 1. And therefore x will equal 1 over m squared plus 1. So I found my x coordinate here. It's going to be 1 over m squared plus 1. Now, I want to find my y value. So I'm going to put that value into this equation, because that'll be the easiest one to find my y value. And I'll do it over here, so I'm trying to keep as much of it on the screen as possible. So my y value will equal m times 1 over m squared plus 1, because that was my x value. Put that in for x here, and I get this. So I get m over m squared plus 1. So I now have the coordinates of this point. I know that it's going to have an x value of 1 over m squared plus 1 and a y value of m over m squared plus 1. So I can now find this distance, because it's basically going to be 1 minus 2 lots of this. So that gives me the x coordinate here. So this value here, let's call this a. So a will equal 1 minus 2 times 1 over m squared plus 1. And my b value was just going to be 2 lots of the y value here. So I'm going to have b will equal 2 lots of m over m squared plus 1. So that's all nicely simplified. Let's just make a look a bit prettier. So a is equal to 1 minus 2 over m squared plus 1. And what we'd like to do is try and write this as a single fraction. So I'm going to times top and bottom of this by m squared plus 1. So a equals m squared plus 1 over m squared plus 1. That's the same as 1. Minus 2 over m squared plus 1. Now I am ready to take these away. So I can do m squared plus 1 minus 2. So a is equal to m squared minus 1 over m squared plus 1 because I've taken the 2 away. So my coordinates are going to be, that's my x coordinate, m squared minus 1 over m squared plus 1. And my other coordinate is 2m over m squared plus 1. Okay, next question. We're going to simplify this. A little bit easier than the last question. We're just going to go through the process of doing the powers on the top and the bottom, and then we'll simplify. So we're going to get 3 cubed. I'm not going to work this out because it may cancel. You never know. x2 to the 3 is going to be x to the 6, times them together. Y to the 3 is y to the 9, times 2 to the power of 4. X to the power of 4 to the power of 4 is x to the 16. Y to the minus 2 to the minus 4 is y to the minus 8. All over 8, which is 2 to the 3. I'm going to write it as a power because then I can cancel. Now this means to the power of a quarter. So I've got 16x to the 12, y to the 8 to the quarter. So 16 to the power quarter, that's just going to be 2. Okay, should know that 2 to the 4 is 16, so raise to the power quarter, that times together gives you 2 to the 1. So it's just 2. X to the 12 to the quarter, times these together gives you x to the 3, times the 8 and the quarter together gives you y squared. So we can cancel out all these 2's. I'm left with 3 to the 3, which is 27. We've got x to the 6 minus 3 is 3, plus 6 is 19. Sorry, plus 16 is 19. Y to the 9 minus 2 gives me y to the 7. Minus 8 gives me y to the minus 1. And there's my answer. Okay, we have a regular emagon and a regular enagon and a regular piagon share a vertex, pairwise share edges as shown. So pairwise means the enagon and the piagon share this edge here and so on. Now find the largest value of p. So what we want to do is to find regular polygons where the angles add up to just more than 180. What's the lowest number that we can get to more than 180? Now, if this is a square and this is a square, that gets us to exactly 180, but we can't get a polygon with an interior angle of 180 because it's a straight line. Therefore, there is no sort of angle bringing it back round to create a polygon. So we know that the m and n must be more than 4. So we start off with, we could have m as 5 and we could have m as 4. That's one more on that. And this gives me an interior angle of 108 over here. And this gives me an interior angle of 90. Okay, so therefore the sum of the, so if that's 108 and that is 90, the sum of those is going to be 198. So therefore this interior angle will be 360 minus 198, which equals 162. So therefore the exterior angle of this is going to be 180 minus 162, which will give me 18. And therefore the number of sides is going to give me 360 over 18, which gives me 20. Now, is that the most we can get? Well, I don't think it is. Okay, let's think about what happens if we have, say, a 3-side. So that was the lowest we can get if we have a square as one of them. But if we have a triangle as one of them, so we've got 3 and we've got an interior angle of 60, what's the lowest, what's the number do we need to go up to make sure this is bigger than 180? Well, if you've got a six-sided shape, that has an interior angle of 120, which means you get to exactly 180. So the seven-sided shape is going to be the one we're looking at. So let's see if that works. So basically, the exterior angle is going to be 360 over 7. And if we take that away from 180, we get an interior angle of 900 over 7. I'm going to leave it like this. And then I'm going to add that to that. So if we add these together, we get 1320 over 7. So that's the interior angle all the way around here. Now I'm going to take this away from 360 like I did there. And I get 1200 over 7 for this interior angle. And if I do 180 minus that, I get the exterior angle, which comes out as about 8.57 degrees. So we know we've got 8.57 degrees. So if we do 360 divide by that, now it's important you use your whole calculator display here because otherwise it won't work it out exactly. So if we do 360 divided by that answer, we get 42. And that must be the largest value of p. So p must equal 42. There is no other way we can do this. And we can't have anything less than 7 to go with the triangle, if this is a triangle here. And also, we can't go anything more than this, these two. Okay, if we have a square here, we can't go anything less than 5 to get an answer here. So by process of elimination, we only had to consider two examples to realize our final answer is that p must have 42 sides.